Dear friends, welcome to my channel. My name is Johannes. In today's lecture session, I am going to discuss about numerical solution of nonlinear and transcendental equations. So let's proceed. So these are the main topic outlines for this chapter. We have numerical solution of nonlinear equations and also transcendental equations. So the first topic is bisection method, how to solve nonlinear equation. We will see the detail, and also Regula-Falsi method, Secant method, Newton-Raphson method, and the last one is fixed point iteration. Okay, before I go to the detail of this chapter, we shall speak few points on learning objectives. So at the end of this chapter, you'll be able to know the graphical interpretation of the false position method and why it is usually superior over the bisection method. And also you will be able to understand the difference between bracketing and open methods for root location, and also understand the concepts of convergence and divergence. Use the two curve graphical method to provide a visual manifestation of the concepts, and know why bracketing methods always converge, whereas open method just may sometimes diverge, may not converge. And also realize that convergence of open method is more likely if the initial case is close to the true root. So I think the number of iteration depends upon the initial guess or the initial assumption you give to start the iteration. So just more likely if the initial guess is close to the true root, and understand the concepts of linear quadratic convergence and their implications for efficiencies of the fixed point iteration and also Newton-Raphson methods. And you will be able to know the fundamental difference between false position and secant methods and how it relates to convergence of these functions. Let us see the detail now. As introduction, what is nonlinear? What is nonlinear? An equation just involving variables which contains at least one term with exponents other than unity, which means more than 2. It could be second degree, third degree, etc. polynomial function, or any explicit or implicit nonlinear function of the particular parameter which we want to solve for. And as the example, we can just suppose that dv by dt, which is acceleration, if it is constant, which means different from 0, there is a constant acceleration or just a body force such as gravity acting on objects. Then the relation between distance s and t becomes, this equation, which is just for any object which is moving, just if acceleration is varying. So initial s naught you have, then v naught t plus just half at squared. So where v naught is the initial speed, this equation has nonlinear relationship. Clear? Nonlinear relationship between the distance s and the time t, because it involves the square of the parameter t. So this is just sample, just nonlinear equation. So let us start now. Bisection method, interval halving, or just half, or Bolzano method. So bisection is a systematic search technique for finding a zero of a continuous function. First, the function should be continuous within any interval. Then if there is sign change between the two intervals, then the method is based on the first finding of an interval, which is a zero known to occur, which means a function may cross the x-axis at some point. So the bisection method is a successive approximation method that narrows down an interval that contains a root of the function f of x. So we will just approximate. And the bisection method is given an initial interval, for example, a comma b, which is a function, should be continuous within this interval, within this interval that contains a root. We can use the property sign of f of a different from sign of just sign of f of b, which means the product of f of a and f of b will be less than 0, which means negative. So to find such an initial interval, so we will use this sign change f of a and f of b should be different signs. So the bisection method will cut the interval into 2 halves. So we will cut into just equal segments and check which half interval contains a root of the function. We will check. So the bisection method will cut the interval in halves until the resulting interval is extremely small, which means just near to 0. So the root is approximately equal to any value of the final very small interval. So we'll just, let me show this graphical representation. So this is a bisection method. We cut the interval. If this is f of x, you have f of x function. This is f of x. Then if you have a at this point and b at this point, then you have just f of a. For example, this is f of a, which is just negative. You can see just less than 0. Then f of b, which is just this one above the x-axis. So you have positive results. This is positive, but this is negative, clear? So this function may cut the x-axis at some point at this point. So to find just this point, you have to just cut at the midpoint, which is this one, which means midpoint, which is a plus b over 2. So we cut the interval ab in the middle, which is half. So a plus b over 2. So which means x1 plus x2 over 2. Then if you just have sign change, the function should cross between this interval. So you can have successive approximation using this equation. Just xn is equal to 1 over 2 a plus b, or just or you can make n plus 2, which is the algorithm 1.2 xn plus xn plus 1, where n starts from 0. Then you have just x0 and x1 first. Then you will find x2. Then it goes on like that. Or using this algorithm, you can make n is equal to 1, 2, 3. Then for initial interval, you have x0 and x1. Clear? x0 and x1. So we just sum up and divide by 2. So if there is just something f of the first coordinate equal to some positive or negative, then the second again just opposite. So choose a and b as 2 guesses for the root, such that f of a multiplied by f of b should be less than 0 to get the root. Or in other words, f of x changes sign between a and b. So the function should be just continuous between this interval. And this was demonstrated above, as just shown in the above sketch. Okay, so now you can check for the following, which is x midpoint, which is lower, just lower coordinate, which means x0, or this is upper x1, you divide by 2, where xm is the midpoint of the lower and upper values. Then if x1 or if x lower multiplied by just the mean or just the mid f of xm less than 0, then the root lies between lower and the mid, which is just we are going to calculate. Then xn is equal to x lower and x upper will be x mid. Then we continue like that. If x lower multiplied by f of x mid greater than 0, if positive, then the root lies between the mid and the upper portion, so that there is change. Then xn equal to lower is equal to the mid calculated above. Then x upper will be x upper. Then if x lower, f of x lower multiplied by f of xm equal to 0, then the root is xm, only one root. Stop the algorithm if this is true. So we have these three conditions for calculation purpose. And the second method is Regula-Falsi method or chord method. So let given f of x is continuous in a closed interval a such that f of a multiplied by f of b less than 0, then that means there is a root which lies between a and b, which means the function should cross between this interval for a given f of x. Then just a times f of, then for a, f of a and b, f of b are the 2 points on the curve, this one. So this is just coordinate, which is a comma f of a and b comma f of b are the 2 points on the curve f of x. For example, you can see this is just x lower limit, f of x lower, you have this. This is a function, and this is upper. So you have this point, f of x upper. So the function should cross at some point, so that it will be just false position. You just first you have bisection. If you divide x lower and x upper, you can have midpoint. But we are just constructing a line which is chord. A chord is drawing to this point. Then so that this function is approaching to this point. Then you have just the root, which means just xn, you just have this algorithm, you can use this one, just b times f of a minus a times f of b over f of a minus f of b, or a times f of b minus b times f of a over f of b minus f of a. So from the equation of this line, this is a straight line, you can see, just you can have two coordinates here, and again two coordinates you have. Then you can write this equation until the function is just meeting this point. You just do iteration. So you have iteration xn plus 1 is equal to xn minus 1 minus xn minus 1 times f of xn minus 1, then f of xn minus f of xn minus 1. So slope of this line. Then this curve should meet this one until just both lines in the curve just intersect at each other and crosses the x-axis, so that y will be 0 here. Just y will be 0. Then you have to iterate. So if n starts from 1 to 3, if you substitute here 1, then you are going to calculate x2. Then this is x0. You are using x0. It goes on like this. So that's the equation of the chord joining the 2 points a comma f of a. For example, if this is a, then this is will be f of a. Clear? F of a. So the line joining these points b, if you say this one b, f of b you have, then as follows. This chord will meet the x-axis when y equal to 0. Clear? So this line intersect. That means for y equal to 0, which is for the function, y is equal to 0, the resulting x is approximated by this equation, y minus f of a equal to f of b minus f of a over b minus a times x minus a, which means this is the same as this one. So you can just iterate. So this is the curve. So you have just f a comma f of a and b comma f of b. So you just start from here. Then this line is approaching to this direction until just the root is just crossing to this point. So this is just the last line, which is intersecting the x-axis where y is equal to 0 as origin, and the curve is this one. This is f of x. Clear? So you are approaching this line, so that just a line is drawing. Then you are approaching to this direction, so that just this chord where y equal to 0 and the curve f of x equal to 0, then it will be the root. And the third method is secant method. So the secant method is a very effective numerical procedure used for solving nonlinear equations of the form f of x equal to 0. It is derived via a linear interpolation procedure and employs only values of f of x at approximations to the root of f of x equal to 0. Hence, it computes f of x only once per iteration. You can see just you have here, for example, just if you have theta, then you can just have xi and f of xi. Clear? If this is xi, then you are just going to this direction, xi plus 1. So tan theta is just here. The difference of this one divided by this one. So I think you are just approaching the same secant line. You are drawing a line which is joining the 2 points so that you will just have a solution. So this is just the algorithm for computing successive approximation xn plus 1, xn minus xn minus xn minus 1 multiplied by f of xn over this one, where n starts from 1, 2, 3, 4, etc. If you substitute n1, you are just calculating x2 because you have x0, x1 initially. Then just you are approaching to this direction so that the curve and also the point, which is at this point or at this point, you are just approaching. So this is just you have secant, clear? Secant. Then if you draw again, then you will just have this point, which is the root. So this is just a secant, which is drawn like this. So this point and this curve will meet at 0 when y is equal to 0. Then finally, you have a real root. And the fourth one is Newton-Raphson method, which is tangent method. Tangent method. Given an initial guess of the root x0, Newton-Raphson method uses information about the function and its derivative at that point. To find a better guess of the root. So we are going to use the derivative of the function at that point, which means dy by dx should be equal to 0, so that you will just have calculation. So f of x is assumption, f of x is continuous and first derivative is known. Then initial guess x0 such that f derivative x0 different from 0. The first derivative different from 0 is given. Then you will just have successive approximations. You can see tan alpha, which is this one, this angle, is equal to AB, this side, divided by this side. Then, which means you are just have the derivative of the function at any point, which is just f derivative xi. F derivative xi, which is at this point, will be just f of xi, for example, divided by xi minus xi plus 1, this one. You see? Just dy by dx, which means dy by dx, changing y by changing x. So if you just crisscross this one, you will get this equation. So for every xi plus 1, I starts from 0, then you are just approaching tangent to this curve any point. Then finally the tangent will be at this point. The curve and the tangent will meet when y is equal to 0. So this is the general equation for Newton-Raphson method. So xn plus 1 equal to xn minus f of xn over f derivative of xn at that point. So where n starts from 0. So you can start 0 here, then x1, x0, you have x0 initial. You may start at any point, then you are just going to this direction if the curve is like this. Otherwise, you may go to the right direction. So just algorithm, you just start with this one until the iteration stops. And what are the conditions for convergence of Newton-Raphson method? So these are the conditions, which means absolute value of f of x multiplied by second derivative of f of x, f derivative second derivative x less than f derivative x the whole square, absolute value. So if this happens, then the function may converge or the root will converge. So steps for this method, use the property, just the first property, find A and B where the roots lies between. If there is sign change, then you will just start. Then the initial approximation x naught is, for example, A. If the initial approximation x naught is B, if in the interval, just if the interval, this one, then you start the same. So use the formula and continue the process. You will continue the process until it converges. If the difference between two successive or consecutive values of xn plus 1 is very small, then we stop the process, and that is the root of the equation. The root of the equation. So as a note, we can just keep in mind these remarks. The process will evidently fail if f derivative x equal to 0, which means if the slope is just nil or 0 in the neighborhood of the root. In such cases, Regula-Falsi method should be used. Clear? Regula-Falsi method will be used. So if we choose an initial approximation x naught close to the root, then we get the root of the equation very quickly. Very quickly we will just find. Okay, the fifth one is fixed point iteration. Fixed point iteration or substitution method. So successive approximation, just we will have substitution. So just the previous value will be substituted for the next iteration. So let f of x equal to 0 be given equation whose roots are to be determined between this interval. So if you have these intervals, then find f of a first and f of b with opposite sign. Otherwise, you will just approximate another. Then write the given equation in the form of this one. X is equal to g of x. X is equal to g of x. If you have some equation, then try to put x to this direction to the left and g another function we will rearrange. With the condition, absolute value of g derivative x less than 0 for convergence. G derivative of that number should be less than 1. Absolute value for convergence. Otherwise, when absolute value of g derivative of x greater than 1 implies that g derivative x greater than 1 or g derivative x less than 1. When it takes out from absolute, then it is divergent, no solution. So divergent and convergent should be checked for fixed point iteration. Then the iteration shall not be recommended to continue. Otherwise, you have to stop your iteration because it is divergent. So let the initial approximation be x naught, for example, which lies in the interval a, b. Continue the process using this algorithm. Just xn plus 1 equal to g of xn. G of xn, where n starts from 0, 1, 2, etc. It goes on like that. Then first approximation, x1 is equal to g of x naught. So once you get this result, then second iteration will be x2. You substitute this x1 in this one, in the function, etc. You will proceed like that. So if the difference between the two consecutive values of xn is very small, then we stop the process, and that value is the root of the equation. Clear? So this is just, for example, if x1, if you have this x1, then g of x naught. You substitute g of x naught, just the interval you have, then you proceed. For example, this is x3, you have g of x2, you substitute, then you get the value of y here. For each iteration, you are just approaching. Then finally, you will just have the root of the equation with successive approximations. And what are the main steps for fixed point iteration? Use the first property. Find a and b where the roots lies. You simply calculate f of a and f of b. If there is a sign change, then write the given equation, first equation, the given equation in the form of x is equal to g of x. Bring another x, then another expression to the right side with the condition g derivative x. You test this derivative. If it is less than 1 within the interval, then it will converge. Let the initial approximation be x naught, which lies in the interval, for example, a comma b. in this interval, you may take any number. Then you have to check. After rearranging the equation g of x, you should check the derivative with that number. If it is just absolute value of g derivative x less than 1, then it converges. So you can continue the process using this algorithm. Using this algorithm, you can find xn plus 1 is equal to g of xn, then, or sometimes xn is equal to g of xn minus 1. So for this case, just n starts from 0, 0, 1, etc. For this case, you just start 1, just x1. Then here it will be g of x naught, which is the initial step. So this is x1. You just calculate x1. It goes on like that. So if the difference between two consecutive values of xn is very small, then we stop the process, and that value is the root of the equation. So if it is just approaching, or if the successive approximations are almost similar, you stop the iteration maybe to the fourth decimal or the fourth significant digits, then you may just stop the iteration, but the difference should be very small. Okay, thanks for watching this video. If you have any question or doubt regarding this topic, please write down in the comment section below. I will reply on it. Thanks again.